Hello, everyone. My name is Nicholas Rodriguez. I'm the National Sales Manager here at Practical Data Solutions, and I'm happy to bring up today's discussion, Demystifying Metadata and Data Fabric for Healthcare Professionals. And joining me today is Russell Hendrickson, the CEO of Practical Data Solutions. Russell?
This whole discussion today came about because I was reading a consulting article from a major IT consulting firm, and they had used so many different buzzwords in talking about how to structure data and try to relate how to make sense of your data. And I thought this would be a great topic because I had to read the article two or three times just to start to understand with all these words and jargon what was going on. So that's what we're going to be doing today. We're going to explore some of these different topics like metadata and data fabric.
Yeah, certainly a lot of different terms out there, Russell. I think it's one of the hardest part, especially if you're new in healthcare, to kind of wrap your arms around. But in any way, if you're not familiar with Practical Data Solutions, the reason we're really talking about this today is because we're a healthcare reporting and analytics company. And we've been doing this now for about 25 years, helping organizations be successful with all kinds of different data, whether it's, operational data, clinical data, and financial data, just as in a few examples.
So as I mentioned, in the world of analytics, and even we're going to talk and relate this to healthcare analytics, but there's a lot of jargon, as we just said. And I think two of the most misunderstood but often used words that you hear and read is this metadata and data fabric, right? So we're going to explore those two words and we're going to break them down and try to simplify them so you can understand and have a better feeling for what are these two words, what do they mean when I'm hearing them, and then how do they relate to better analytics and reporting in healthcare.
So why don't we jump right in, Russell, and talk about, what is metadata?
Yeah, so metadata, you hear this term all the time. Metadata is data about data. What? Right? Yeah, data about data. So it's really explaining what the data is. It's the data descriptions, it's the data details, right? Or you could call it the data tags. So very simply, when we have data, let's say it's billing data, it's charges, payments, and adjustments, right? But we need more than just charges. Is it gross charges, net charges? Right? Is it payments that include maybe adjustment codes? Is it denial details? Where's the data source? Is it internal claim edits? Right. So being able to understand your data requires, almost like a data catalog. So when we talk about metadata, we mean the details behind the data that you're working with.
Excellent. So moving on quickly here, what is data fabric, Russell? How does that relate?
Yeah, that's a great question. This term data fabric, and we'll go back to the origins, but the idea is that when we connect data, it's woven. It's the idea that we can connect all of our different data sources, all those different applications, the EHR, the general ledger, the survey data, the call center data, the quality data, the data coming from the lab machines, even, right? We can connect all this data, and in connecting it like a fabric, we can weave it together. That's the term about data fabric. It helps us weave it all together so now we can connect to it and have access to it. So it's that concept, just like woven, fabric is woven, we can weave data.
That makes sense. Okay.
So data fabric, though, isn't a physical thing. It's an architecture. It's a way to structure data. It's not a physical product. It's a way to put your data together really as like a strategy or an approach, right? And what's interesting, though, and we're going to have to discuss some of these other things, is data fabric really needs to leverage other proven modeling approaches like the star schema, which we're going to break down, like materializing data marts and even governed dimensions. And we're going to break down those topics, right? So you still need people to build your architecture, understand how to structure your data, and then put in the rules. So when you're working with the data, it all works together. So we're going to explore all of these different areas in today's discussion.
Okay. Now, conceptually, that sounds somewhat familiar to something I've heard before. So, is data fabric really new or?
Yeah. So what's interesting is, and I didn't even realize this, I only in the last probably year, 16, 18 months, started hearing about Fabric and what is data fabric. And then we'll also talk about Microsoft Fabric because they have a product called Fabric. But it turns out Gartner had been sort of promoting data fabric as a concept or an architecture for joining and building complex data environments going back to 2019. And they define data fabric as a concept that serves as an integrated layer of data and connecting process. So again, that idea of weaving, together data, connecting them.
Okay. So, in the past, I've heard of similar concepts described as things like, data warehouses, which are, more centralized data stores, or, data lakes, which are, more raw, unstructured dumps of data. But I've also heard things like data mesh, another concept for focusing on more decentralized data data ownership there. But I think data fabric kind of stands out to me a bit because it emphasizes the interconnection automation across everything, almost like you said, like a woven system of data.
Yeah, Nick, and so, to me, data mesh is kind of a newer term that I've heard kicked around a little bit, not as popular. Certainly everybody knows about building data warehouses. That's not a
Hmm.
new concept at all. Then we have though data lakes, which to me, data fabric is kind of the next extension off of what is a data lake. And in part, it's because our technology's gotten more powerful. So we're going to explore even what's a data lake versus data fabric versus a data warehouse. But you're absolutely right. Data fabric is really this next generation of thinking about how we connect data and how one might go about building sort of an interconnected highway to make everything work.
Okay. And I imagine there's some things to be mindful of, when you're thinking about, data fabric, right?
Yeah, without a doubt. I mean, again, the term data fabric is really this newer evolution of thinking, connecting all our data, but it's all built on technologies and practices that we've been using, everything from data integration tools to having good catalogs, ETL, and even this term virtualization layers, which is really a way to enhance performance when we start connecting data. As far as challenges with data fabric, just like any other structure or architecture, it's only good as what you build, right? And so we go back to this: if your metadata, if your data about data is wrong or not well defined, you're not going to be able to make good decisions with your data, right? One of the biggest challenges to sort of this concept of data fabric is that if it's not maintained, and they call it your fabric will fray. Well, it's not really
Hmm.
fabric, but it's just not going to work the way you want it to. So if you don't have a good structure, you don't understand the metadata, the data about data, right? Data fabric may just make things more confusing. Okay.
That's really interesting. So, if I had to kind of summarize my understanding of this, data fabric can really be thought of as a smart highway system, right, Russell? It's really a way to connect all your data in ways that it can be accessed quickly and and found quickly and used quickly if needed. Is that a
Yeah,
fair
absolutely.
statement? Yeah. Okay.
No,
Great.
I think you're right on. Think about it as a way to connect all of those different data sources that you might have, all the different pieces of data, which could even get as granular as, we have pacemakers that are on monitoring and they're being reported back to a server in our health system. And we want that data to be able to integrate with all of our other data, our quality data, our clinical data, right, our follow-up data. So if you think about it, it's kind of a neat analogy as a highway system. Then we also need to build in those labels, the metadata about all the different data that's available in that highway system. And then we also have to sort of have rules about how we can join data, kind of like a highway. We've got to have speed limits, we've got to have stop signs, we've got to have different ways to work with data. So when people start to use this highway system to access data, they know what they're working with and they know how it can be used.
I really like that analogy. It kind of helps paint things very clearly there. And I would imagine, like designing a highway system, there's probably some things to consider when building a smart data system. That right, Russell?
Yeah, without a doubt. It's very similar. And some of these rules haven't really changed, whether we're building a data warehouse, we're building a data lake, or we're trying to build data fabric, right? And that is how do we start or where do we start? Number one, right? Talk about labeling your data. This goes back to where we started, the metadata. If you don't know what the data is or where it's coming from or how, what the actual description of data is and it's accurate, you're labeling it, building a catalog that just isn't going to work. So we've got to start by labeling data. The second thing is it's not like you can build the whole city all at once. You really got to think about it a piece at a time, sort of like building a structure. Maybe we have to build the main highway before we try to build the side roads and all the exits, right? So we have to think about doing this iteratively. We have to think about doing it in steps, right? And then, of
Hmm.
course, as you start connecting data, we've got to make sure we've got the labels and the data available to those analysts or programmers who are going to be using it so they really understand what they're working with to help then define the reporting for the end users. So to kind of summarize what we're talking about here, we want to start small, solve a real problem, probably pick one or two meaningful cases, build a model around it, and then of course then we can start to expand it, right? One of the key concepts though to data fabric that's different than the traditional data warehouses or the data lake is we don't want to copy data, we just want to connect it, right?
Hmm.
And that's a distinct difference. That's why we're weaving the data sources together and 5, 10 years ago, that created all kinds of performance issues. We didn't have the systems that could really handle that. But today, with the technology just getting more and more powerful, this concept of fabric, leaving the data where it lies and just interconnecting it is very real.
And I like that you brought up, 5 to 10 years ago, talking about how we might join data. Because in the past, we'd really use, star schemas to do those types of things to join data. How does this kind of fit in there, Russell?
Yeah, that's a great question. So, first off, let's define what that star schema is. So, a star schema is really a structure where we have the fact table, i.e., we saw all these patients and they had these visits, or we had these charges, or we had these claims, right? And then with the associated dimensions tables, which are somewhat the facts that describe the data, right? Which is the provider or the payer or the location, right? So the star schema is probably the longest running traditional way of approaching modeling data. It's very fast, it's great for structure, but it really applies to a single data set or
Mm.
one sort of fact table. So it might be one little road in your bigger fabric highway system. With data fabric, that's the whole idea that we're going to connect all the data sources. So we're going to weave everything together and put it all sort of in a structure that's available to our power users who can then pull data from any application. So it's a little different. Star Schema is much more, micro, data
Hmm.
fabric, much more macro. Right?
Okay.
One of the neat things, though, and we've talked about this in the past at different PDS webinars, is we can build different star schemas off of different data sets. And what we do, conform the dimensions. So the provider and our patient satisfaction data now joins to our provider and our scheduling data. And so you can use this sort of join schema ability to start building out a data warehouse, right? And so you might say, well, how is that different than data fabric? Well, in data fabric, we're not really trying to conform all the data. This works great for the end users who can then self-service,
Mm,
right?
okay.
So this is again, we're being much more sort of micro focused. I want to be able to give the end users the ability to look at, let's say, physician productivity, associated expenses broken down by physician, time it takes for a patient to get an appointment to that physician, and even how long they're waiting in our call center, as an example, right? So Star Schema much more focused, where we're bringing all the data together to make it much easier to report on and even deliver it self-service to the end users. If we contrast that with data fabric, though, that's not really the approach. In data fabric, we're connecting all the data, but unfortunately, we still need somebody who can then shape the data and make sense of it. So what's very common is even with using data fabric, we may then have to build star schemas or build a data warehouse where we need to be more micro to getting the data to line up and provide the metrics and the analysis that the end users want. Does that, connect up?
Yeah. So if I'm kind of understanding this, some of the differences, right, between the two is a star schema, really works where there's one database and it connects with shared dimensions. Really kind of built for speed. Is that a fair statement?
Well, speed
Um,
and ease of use, though. Ease of
oh,
use for the
true,
end
true.
users. Yeah,
Yeah, for more
yeah.
self-service. Good point. Good point.
Hmm.
Where data fabric is more designed to be built across all the different systems you may have, and it connects with things like metadata, virtualization, and smart mapping. Um, it's also a little bit more flexible and diverse for dynamic needs, and it can kind of be used across the organization.
Exactly. Yeah. So if you think about a star schema is almost like giving the end user an application on their phone, right? The end
Hmm.
user, right, can go in and go click, click, click. It's all structured. It gives them exactly what they want. They don't have to really think about the definitions because they've already been defined, right?
Okay.
Data fabric is a little more like giving the programmer the phone and saying, build what we need for the end users. You have all of these different data sets and tools available, but the really the programmer has to make it join and pull it together. So better for we're trying to explore data, we're trying to figure out how we're going to build it, we're trying to figure out what we want to deliver to the end users, much
Hmm.
more big picture versus star schema, which is, think macro versus micro. That would be my best
Gotcha.
analogy for that.
Okay.
Yeah.
That
Yeah.
makes a lot of sense.
Hmm.
So Russell, can we explore a bit more about, conformed dimensions and what that entails?
Yeah. So, I mentioned this, in the star schema, we have to use conform dimensions. So, conform dimensions is a perfect example of, we need standard tables that allow us to join data. Well, what does
Hmm.
that mean? Okay. Well, you've got data coming from Press-Ganey, you've got cost centers in your general ledger, and then you've got your EHR. Maybe it's Epic, right? So, there's a definition of the provider in the EHR system, and that provider might be, ID 21. But in
Hmm.
Press Ganey, they might just call it Dr. Smith. And then in your general ledger, it might be cost center 111 for those direct expenses to the physician. So a conformed dimension is a way of stating that the data in the Press Ganey data, this provider, Dr. Smith, equals the provider ID in the EHR, which equals this cost center for direct expenses. So it's a way of saying all of these data, even though they're coming from different tables,
Hmm.
join or match, and much in a one-to-one relationship. Okay. So we can do that in a star schema, and we can even join and copy the data in and then build that relationship. But in data fabric, it gets a little more abstract because the concept is we haven't really staged all the data. So we still have to build rules and layers that people can use. We have this other topic, which is the semantic layer. You hear this a lot, right? And so, metadata is what is the data, right? So it's charges, payments, adjustments, it's clinical data, it's quality data, it's the medical history of the patient. What is the data? The semantic layer, though, there's another fun term, is how do I use this data to answer a business question, right? So think of it as what is the data versus how do I use the data? So what is the data might be what is our denials, our denial that are coming back from Aetna. The semantic layer might be how do we use the data, i.e., I want to know when we get a denial, did we ever get paid? Was the data recovered or did we end up writing it off? And how quickly did we get paid? So it's really understanding the business questions of what's going on with the data. That's really the semantic layer, which is where the business logic lies.
Or how
And,
do Aetna's denials compared to Blue Shield or, something like that, right?
exactly right. So it's how do I use this data to answer questions for the decision makers, which is a little different than how do I program the data to join into a report.
Okay.
So to simplify metadata versus the semantic layer, right? Metadata, data about data. And a great example might be we have this field that has a date in it, 7/15/01, and then it was created in our EHR system and it last updated June 1st. That would be what you have in metadata. Where did it come from and what is that field relate to? But in our semantic layer, it's really business logic. This is what the end user or the finance or the admissions manager might use, which is length of stay. So that length of stay, which equals the discharge date minus the admin date. So that gets us our length of stay, and we can run across all of our different DRGs and procedures that are being done. Right. So it really comes down to the business logic versus the metadata. And that's a great way to think about the two. Right.
Hmm.
One is useful to the end user, one is really what is the data?
Excellent.
So, when we think about conform dimensions, then, and we think about where do they live in fabric, right? Typically, the primary home of these conformed dimensions is going to be in the fabric, but they don't necessarily have physical tables. That's what makes this so
Hmm.
different than, say, having a star schema or a conformed data warehouse. They don't have physical tables. They may just be built into the rules as we start joining the different data sets. But this is where it gets a little bit fuzzy sometimes, because if you start to think about it, you go, how are we going to make sense if we have so many different data sources? So that's when we may want to bring in something like, a master data management system. And to me, a master data management system is something almost like having a card catalog in your library, right? If anybody remembers
Hmm.
that. And I'm probably dating
I
myself
do. I do actually.
because right, those old card systems, but it's a way to organize all the data and try to make sure that the labels and the way that the data is interpreted can be meaningfully understood. So it's sort of like a better metadata structure and system. But then again, as we keep advancing our fabric, these are the kind of things that most organizations have to start thinking about building is that master data management. Some of the other ways to use data is we can create virtual views or logical models. Virtual views are just layers to make the data easier to work with. Also can make the data more real time or faster. So we can start to apply these views that give us that ability to put more of the semantic layer in place. And most of the time, as we start materializing views, this is done for performance. In
Hmm.
going back years ago, the ability to sort of have data not in one place was huge performance issues, especially when we started working with a lot of data. But today, because the technology's gotten so much more powerful with cloud servers and AWS and those kind of things, it's much easier now to sort of join data and build these rules into place.
Yeah, it's been really interesting to see how the technologies almost shape the way we work in that regard, right? You'd almost think it'd be the other way around, but
And as I mentioned, some of the challenges is who's going to manage that master data management when you think about a big health system, because there's just literally hundreds of different servers, data sets, databases that you're trying to join. So,
well, even the
I
differences of those different data sets, right? It
exactly,
might be difficult
yeah,
for that person to
yeah.
kind of understand all of them because there's so much in healthcare, like you said.
And so this is one of the big things that, the concept of a fabric is to me, it's sort of the ideal, but realistically, because you may not have clear ownership, somebody may not understand all the different areas that the data is coming from. So you really have to sort of prioritize. So it's more of a goal. We want to get everything into our data fabric, but you probably can't get everything organized the way you want because there's just so many different sources of data, right?
Mm.
So you still need somebody to go in and sort of understand the data before you can join it across systems.
So, we got to think about how do we handle those one-to-many relationships. For example, there might be one patient that has multiple visits, which has multiple procedures, right? Or, those multiple visits might produce multiple payments and multiple denials, right? How do we handle some of those challenges, Russell?
Yeah, so I mean, this is the fun part about healthcare data, probably more than any other data set that you find in business. We're just, one to many everywhere.
Hmm.
Like one patient could see multiple doctors in the same visit. One visit could have multiple procedures. One Multiple procedures can have multiple modifiers, multiple payments, multiple adjustments, multiple denials, these one to many. We think about clinical data, quality data, right? You can have
Hmm.
one blood draw can have, literally 20 different results in a chem panel. So we've got to handle these things. And, the reality is the traditional star schema is very good at handling one to many relationships, right? But in data fabric, it gets a little more challenging, which is why oftentimes we have to combine different techniques to join one to many relationships using sort of star schemas within our fabric potentially. So it's just, again, this is an architecture, it's a concept, it's not a physical, just go do it, right? It's an approach. So in
Hmm.
many cases, we have to really draw on some of the traditional techniques when we handle and run into those one-to-many type relationships. And Nick, you bring up a good point. This is can be a stumbling block sometimes to designing your fabric.
Well, yeah, and especially in practice, I would think we would need to consider, the performance of putting all this data together because there's got to be some real concerns, I imagine, when joining that much data. How's it going to impact the performance of things moving quickly still, right?
Yeah. So again, the complexity of data. If we've got to restage data because of those one-to-many relationships, we may have to rely on the more traditional concepts. At the same time, joining all the data and putting it into a single data warehouse or a single
Hmm.
star schema model, that can make your data very redundant and can also slow performance. So it's kind of a balancing act.
Okay.
But, oftentimes this concept of fabric, we have to still rely on traditional concepts is what I would say. So depending upon the complexity of the data and what you're trying to do. So there isn't, it's not a single just do it this way. It doesn't quite work that way, but it does give us the ability to, interrelate different concepts when we're building out our structure.
Okay. And I know we kind of touched on this earlier, but can we maybe go a little deeper into how does this differ, compared to a data lake versus a data warehouse?
Yeah. So the biggest thing that with the data fabric, the idea is we're trying to leave the data in place in the application or in the application's, data databases.
Mm-hmm.
Um, with the data lake, the idea was we were pulling all of the data into a single quote unquote lake, right? So
Okay.
all the data sat in one bigger server, wasn't necessarily joined or conformed, but at least it was all available. And that way, as you worked with it, you were you've simplified access to the data. So data fabric is really, to me, the next step beyond a data lake. It's sort of data lake keeping data lakes, if you were to think about it that way with
Interesting.
fabric. It's multiple lakes versus a single lake. The data warehouse, again, much more micro. We're going to pull together the data. We're going to
More
copy the data
structured too, right?
in.
Okay.
Yes, and then we're going to define and really structure it down. So the data
Okay.
warehouse much more for the structuring data for self-service, structuring data that is clearly labeled, structuring data that the end user really can't get into trouble. So think of it as more the data warehouse is often better for the finance and operations person, where
Mm-hmm.
the data lake or the data fabric is really more for the data programmer, the person who's actually staging and modeling data to deliver it to the end users.
Okay. So, when I'm thinking of joining a lot of different data together, one business case, in healthcare that comes up to me is physician compensation because we have so many different sources of data, whether it's, patient satisfaction scores, EHR data, maybe general ledger data potentially, right?
Mhm.
Is data fabric a good place to kind of think about
Yeah.
or is doing comp?
Yeah. So that's a great question, right? So your data fabric might be where you start. If you had fabric in place and you could pull all from the different systems, right? So you could pull
Mm-hmm.
from your productivity data, you might pull from your general ledger, you might pull in from your patient satisfaction. So if you have data fabric in place and you want to start building out comp metrics or comp reporting, data fabric would allow you to grab that data, start to pull it together. But the reality is you probably need more of a star schema or data warehouse where you've now
Right.
taken all the data, interpreted the data so that you're using the right RVUs, you're applying the right methodology, you're picking up the right patient satisfaction metrics, and they're conformed or joined because in some cases you might have those one-to-many relationships, right?
Right.
So data fabric would be again big place to start and pull data, but you
Mm-hmm.
probably, think about comp, you probably really almost need to get down to what is more of a star schema or a modeled set of data that is specific to your comp metrics.
Yeah, that conforms to those rules that your comp plans have as well,
Exactly.
correct?
Yeah.
Yep. Okay,
Very
that makes sense.
specific rules. That's your thinking is right on. Yep. Yep.
Excellent. Okay, no, thank you for explaining. That's really helpful. So Russell, I've heard of the term, we've talked about Fabric. What about Microsoft Fabric? How does that play into all of this?
Yeah, that's great. So, Microsoft introduced Microsoft Fabric in 2023, and it was really their version of saying if you use our tools, Power
Mm-hmm.
BI, Data Factory, Data Warehouse, and they've even changed some of these, One Lake, um, which is related to OneDrive. But the idea is they're giving you their tool set so you can now build your fabric. So the idea is, that Microsoft Fabric is a product. Data fabric is more an architectural concept, right? And so Microsoft Fabric is their way of packaging and saying, work with our tools. And if you're using all of our tools, you can build out your data fabric using our products, i.e., the Microsoft Fabric product offering. So one is
Okay,
a product, one is more of the architecture, the concept that we've been talking about.
gotcha. So if I had to summarize, what you just said, right? The Data Fabric is really the architectural design and the concept, and it works great across different vendors. Versus Microsoft Fabric's really Microsoft's platform for that and really works within their environment, i.e. other Microsoft tools and products, right?
Yeah, and you're right on. Now again, with it's not a hard rule because you can connect to databases that aren't Microsoft and still use their tools. But yeah, generally speaking, you're right on there, Nick. Yep,
Okay,
yep.
great. So let's tie this all together, Russell. I like to think of that, highway system analogy we have before and taking it, a bit broader, thinking about maybe a map or the city itself, right? Metadata is really the index on that map or the legend that tells you what each symbol on that map means. The semantic layer is almost the tour guide, helping you navigate the city, telling you how to interpret what you're seeing and, navigate more effectively ultimately. And data fabric's the actual infrastructure itself. It's the roads, it's the highways, the sidewalks. That's really helping you get to all the different data, more destinations, right? As if we think of that example.
Yeah, right on, Nick. I think that's a nice summary to think about, if you want to carry away these different terms. We hope you found this discussion valuable today. Thanks so much for joining us. If you're designing a data warehouse, trying to implement something like Fabric or even Microsoft Fabric, if you're looking for ways to better deliver data to end users for self-service. All of these are topics that we have a tremendous amount of experience with, and we're helping health systems, practices, and hospitals all across the country have right access to the right data the right way, quickly and effectively. So if we can help you, please feel free to reach out. You can certainly get more information. We'd love to talk to you and hear what some of your challenges are. Very likely we could assist you and move quicker in getting to where you want to be with effective reporting.